Algebra 5-1, well, Algebra 2 5-1, operations with polynomials. So part of this lesson, you're just going to copy what I've already written, and part of it I'm going to write and you're going to write. But I wanted to just have you copy down this chart and as I talk through it. So you're going to have this chart that has 3 columns: property, definition, examples. And then there are, well, let's see, 1, 2, 3, 4, 5, 6, 7 rows here. This first one is product of powers. And so we're talking about operations with polynomials. If I have x to the a power times x to the b power, that equals x to the a plus b power. So when I'm multiplying the bases, I add the exponents. So here's an example. 3 squared times 3 to the 4th power equals 3 to the 2 plus 4 power, which is 3 to the 6th power. Quotient properties, quotient of powers, sorry. So if I have x to the a power over x to the b power, then that is x to the a minus b power. X doesn't get to be 0 down here. Same thing as x to the a divided by x to the b. It could be written either of these ways. Same thing, x to the a minus b, x raised to the power of a minus b. And so here's an example. 9 to the 5th power over 9 to the 2nd power equals 9 to the 5 minus 2 equals 9 to the 3rd power. Next is negative exponent. So if you have a negative exponent, all that says is, I'm unhappy here, switch me to the other side of the fraction bar. So x to the negative a is 1 over x to the positive a. Notice it was negative here when it was in the numerator, and then when I switched it to the denominator where it wanted to be, now it's positive and it's happy. If I have 1 over negative b, then I switch from the denominator to the numerator, make that exponent positive, and we're all good there. So here's an example. 3 to the negative 5 is really, or can be written as 1 over 3 to the positive 5. Power of a power. So if I have x to the a power raised to the b power, that is the same as x to the a times b. So notice earlier, if I'm multiplying two bases with exponents together, I add the exponents. When I raise that to another power, instead of multiply it, then I multiply the exponents. 3 to the 3rd power raised to the power of 2 is 3 to the 6th power. Power of a product, property. So if I have x times y raised to the power of a, then that is the same as x to the a power times y to the a power. Notice this is multiplication here. This does not work if it's addition or subtraction. It's got to be multiplication or division, but it can't be addition or subtraction. So here's an example. 2 times k, both of those to the 4th power, equals 2 to the 4th power times k to the 4th power. Let's keep on moving. Power of a quotient is the same as power of a product, but this time we're showing it as division. So x over y raised to the a power is x to the a over y to the a. Y can't be 0 because the denominator can't be 0. So if I have x over y squared, that's the same as x squared over y squared. Zero power. X to the 0 power equals 1. How do I know that? Because x squared divided by x squared is the same as 1, right? X squared divided by x squared is 1. But let's see how we get, another way we can get to 1. 2 minus 2, if I use the quotient, the power of a, if I use quotient of powers property, then I know that x squared over x squared is x to the 2 minus 2, which is x to the 0. So x squared divided by x squared is 1, but it also is x to the 0 power. 7 to the 0 power is 1. So anything raised to the power of 0 is going to be 1, because any number divided by itself is 1. All right, so that's it on the chart. So now I'm going to move to writing stuff out. We're going to do some examples. And our first example is simplify. Here's your example. 2a to the negative 2 power times 3a cubed b squared times c to the negative 2. Okay, so now we're going to multiply all this stuff together. We're going to simplify. And so I'm going to just kind of look at each section in the parentheses by itself, and then I'm going to put it all together. So this 2, I'm not going to multiply anything by this 2 yet. But this a is raised to the power of negative 2. So I'm going to rewrite this kind of underneath here, because it's a little bit easier to see if I just go vertically. So I'm going to say 2a over a squared, because that a squared, if it's negative squared, a negative exponent, then I move it to the other side of the fraction line, and then I'm happy. Now, I've got this times 3a cubed b squared. 3a cubed b squared. Nothing's negative there, so I'm just going to put that over 1 times c to the negative 2, so that's 1 over c squared. All right, now I'm going to multiply all of this straight across here. 2 times 3 is 6, times 1 is still 6. And then a cubed b squared, if I try to multiply that, there's nothing to multiply by there. A cubed b squared. And then at the bottom, I've got a squared times 1 times c squared. So a squared times c squared. All right, now there's a little bit more that I can do here. So we can rewrite this as 6 times a 3a's times 2b's over 2a's times 2c's. And any number divided by itself is 1. So a divided by a is 1, a divided by a is 1. And there's nothing else here that turns into 1. So I end up with 6 times a times b squared over c squared. Let's do, oh, I went into u tries already. Let's do another one. And then we'll do some u tries. So I've got q squared times r to the 4th power over q to the 7th power times r to the 3rd power. Okay, let's see what this looks like here. So we can look at the q's. Q, that would be 2 minus 7, which would be negative 5. So I've got q squared minus 7, q to the 2 minus 7 equals q to the negative 5. So that's going to stay in the denominator. Q to the 5th power is going to be in the denominator. Now, the r's are r to the 4th minus the 3rd. So that is r to the 1st power, positive, so the r will stay on top. Just like that. You could also say, so there are several ways to do this, but so I'm showing you a couple different ways. You could also do it just like we did with this one over here, where we could say q times r times r times r times r over q 7 times 1, 2, 3, 4, 5, 6, 7 times r 3 times. And we can go q's, and r, r, r. And then we end up with one r on the top all by itself, and then 1, 2, 3, 4, 5 q's on the bottom. So that's two different ways to look at this. Let's see if you can do one without me. So I've got negative 2a to the 4th power over b squared. And all of this raised to the 3rd power. So remember, we're going to use this property, power of a quotient property, to say that this gets multiplied, or not multiplied, this gets distributed here, this exponent to the x and to the y. And we're also going to use this one where the exponent gets distributed to the x and the y this way, both of them. So see what you can do on this, and go ahead and pause and get to work, and we'll come back and take a look at it together. All right, so let's see how you did. I'm going to take this exponent here, I'm going to distribute it here to this space, an exponent. I'm going to distribute it here to this one. I'm also going to distribute it here to this one. So each base gets this power of 3 applied to it. So I've got 2 to the 3rd power times a to the 4th power to the 3rd power over b squared to the 3rd power. So I'm just showing that I've distributed that 3 to all of those bases. Now, 2 to the 3rd power, negative 2 to the 3rd power, so that's 2 times 2 times 2. And it's negative here, so negative 2 times negative 2 is 4. 4 times negative 2 is negative 8, so I've got negative 8. And then a to the 4th to the 3rd, I multiply the 3 and the 4 here. So I get a to the 12th power over b, 2 times 3 is 6, b to the 6th power. And that should be your answer for that one. Let's do another U try. 2 more U tries. I'm going to set them both up here. So U try A is going to be 2x to the negative 3 times y to the positive 3 times negative 7, x to the 5th, y to the negative 6th. And then I'm going to have you do another one. That is a over 4 raised to the power of negative 3. Oh, I have several more. Oh, good. C, 15, c to the 5th, d to the 3rd, over negative 3, c squared, d to the 7th, and d here, negative 2x to the cubed, y squared, raised to the power of 5. All right, so you have 4 U tries to do here. Go ahead and pause and get those done. Okay, let's see how you fared here. All right, so this is x is going to go underneath the fraction line, and so is this y to the 6th. Everything else is going to stay on the top. So 2 times negative 7 is negative 14. And then I'm going to have x to the 5th over x to the 3rd. So that this negative 3 tells me to put the x to the 3rd underneath. So I've got the numbers, I've got the x's, now I've got the y's. Y cubed stays on top. Y to the negative 6 now goes on bottom to be y to the positive 6. Now I just need to cancel out all of the ones or factor or simplify here. So I've got negative 14, that's going to stay there. And then x to the fifth over x to the third is going to end up giving me x squared. So 5 minus 3 is 2. And since this one is the bigger number, then my base is going to stay up there. Down here, I've got 3 and 6. 3 minus 6 is negative 3, so that means I'm going to stay down at the bottom at 3. Y to the third power. So whichever one is the bigger one, the bigger exponent, that's where your letter, your variable, is going to stay. I don't know how clear that is, but we'll see it again. Let's do this one. So a to the negative 3 over 4 to the negative 3. Since these are both negative, a to the third power wants to go down into the denominator. 4 to the negative 3 wants to go up to the numerator. So 4 to the third power over a to the third power is what we got here. And so all we have left is to raise 4 to the third power, and that is 64. So you get 64 over a cubed, and that is your answer for that one. Let's look at C. Okay, so 15 divided by negative 3 is negative 5. Negative 5 is going to stay in the denominator. 5 minus 2 here, I'm looking at the C exponents. 5 minus 2 is 3, and 5 is bigger, so C to the third power is going to be on top. 7 minus 3 is 4, and 7 is the bigger one, so D to the fourth power is going to stay on the bottom. And one more, let's look at this one. Okay, so this 5 gets distributed or applied to all these bases here. So we've got negative 2 to the fifth power, x to the third to the fifth, and y squared to the fifth. 2 to the fifth power is 32, and since it's negative, negative times a negative times a negative times a negative times a negative, 5 times is going to give me a negative. Negative 32. X to the third, 3 times 5 is 15. And then y, 2 times 5 is 10. All right, hope you guys did all right with those. I've got some more stuff to go on the back. So we're going to look at degree of a polynomial. So the degree of a polynomial. So this is the degree of a monomial with the greatest degree. So monomial, we'll say like term. Okay, so this doesn't make a whole lot of sense, does it? Let's do an example, and maybe it will. X squared plus 2x plus 5. So I'm looking at each of these terms, and I see which one is to the highest or greatest degree. So x is squared, 2 is to the 1, x is to the 1 power, 5 is to the 1 power. So this variable here, to the second degree, this tells me that this polynomial has a degree of 2. Degree is 2. Let's look at another example. X cubed plus 5x plus x to the 8th power plus 2. So which of these is raised to the highest power? It's this one, x to the 8th. So that means the degree of this polynomial is 8. All right, we're going to look at a few more examples here. What if I have 1/4 x to the 4th power y to the 3rd power minus 8x to the 5th power? All right, here I have only two terms. I've got this term and I've got this term. Now I can see that x to the 5th is the highest degree, but this term here, notice how these are all being multiplied by one another, or to one another. I've got 2 degrees up here as part of this term. And so this is actually 4 plus 3, which equals 7. And this one is only 5. So my degree here is 7. I know, it's kind of gross, it's kind of confusing, but we're going to keep moving. The square root of x plus 4. This is not considered a monomial. And so therefore, this whole mess is not a polynomial. You want that guy?
Are you helping him?
No, get him out of here.
I'll take him.
Get him out of here.
If not, you're coming with me.
So if you see a square root, if you see a radical in here, then you are not dealing with a polynomial. Just ignore it. All right, next. X to the negative 3 plus 2x to the negative 2 plus 6. So x to the negative 3, this is 1 over x to the 3rd power. And this here is 2 over x squared. These are not considered monomials. And so this is not a polynomial either. Okay, so be aware of those tricky things. One more example. X over y plus 3x squared. Same thing. No, not a polynomial. Just stop. Okay, you try. Find the degree of these polynomials. X to the 5th, y plus 9x to the 4th, y cubed minus 2xy. Also, you try this one. 3ab squared plus a to the 6th minus 12a to the 4th, b to the 3rd plus ab. Okay, so go ahead and try these two real quick, and then we'll see how you did. Go. All right, welcome back. This y is to the 1st degree here. So 5 plus 1 is 6. 4 plus 3 is 7. 1 plus 1 is 2. So the degree of this polynomial is 7. This one, a to the 1 plus 2 is 3. A to the 6th is 6. That one's all by itself. 4 plus 3 is 7. 1 plus 1 is 2. This one is also 7. So the degree of this one is 7. The degree of this one is 7. All right, let's do some simplifying. Ooh, all right, getting low on paper. All right, it's okay. Simplify. Negative x squared plus 3x plus 4 minus x squared plus 2x plus 5. Okay, so we're going to simplify this. And this is just subtraction, right? We're not multiplying this one by this one. We'll be doing that pretty soon. But this one is just subtraction. Now, if it was addition, I would just take these parentheses away and add like however I feel like it. But since I have a subtraction sign here, I've got to distribute this negative to each of these terms before I can combine them. So negative x squared plus 3x plus 4. I'm taking away this parentheses. I don't need it anymore because I'm just subtracting. Subtraction, so I'm going to attribute this negative here to the x squared, to the 2x, to the 5. So I distributed that negative. If one of these was minus, then it would change it to positive, to plus. But since these are all plus, I'm going to change them all to negative. Now I can, since I've distributed my negative, I can now combine all of these like terms. Negative x squared and x squared. So I'm going to look at those first. That's negative 2x squared. And then I'm going to look at the x's. So remember, I can only combine like terms, and like terms are terms that have the same variable raised to the same power. So I can't add x squared and x. I can only add x squared to x squared. I can add 3x to negative 2x. That gives me 1x. And then I can also add 4 and negative 5. That gives me negative 1. And so my answer then is negative 2x squared plus x minus 1. All right, so I'm going to have you try one that looks just like that. 4x squared minus 5x plus 6 minus 2x squared plus 3x minus 1. All right, so go ahead and do that one. It's almost the same as this one right here, just a little bit different. Go ahead and pause and do that work. All right, so let's see how you did. I'm going to distribute that negative. I've got 4x squared plus 5x plus 6 minus 2x squared minus 3x plus 1. Negative times negative is a positive. And now I'm going to look at my like terms. I've got x squared, I've got 5x, I've got negative 3x, and I've got plus 6 and plus 1. 4x squared minus 2x squared is going to get me positive 2x squared. 5x minus 3x is positive 2x. And then x plus 1, 6 plus 1 is 7. Oh, this is a negative 5. Oh man, I switched it to positive. So I should have minus 8. Dang, nobody said anything. You guys were just all quiet. Okay, so that should be what you got here. 2x squared minus 8x plus 7, because this is minus 5x. All right, now we're going to look at another problem that you might see on your homework. N plus 4n, n squared plus 4n minus 6 times n plus 2. Okay. Now with this one, so I have a trinomial times a binomial. So before we've looked at two binomials multiplied by one another, and we used FOIL. Now for this, we're not going to use FOIL. We're going to say n needs to be multiplied by all of these things, and 2 needs to be multiplied by all of things. And these are both positive, so that's nice. So what I'm going to do is I'm going to say this n is going to be multiplied by n squared plus 4n minus 6. And since this is plus 2, I'm going to say plus 2 times n squared plus 4n minus 6. So I'm just making sure that n gets multiplied by this whole trinomial, 2 gets multiplied by this whole trinomial. If this was minus here, then I would say minus 2, like that. All right. So now I just distribute this n in there, n cubed plus 4n squared minus 6n plus 2n squared plus 8, plus 8n minus 12. So I've distributed that 2 to each of those terms. Now I find my like terms. I have n cubed, that is the only n cubed. So n cubed goes there. Now my n squareds, I only have 2n squared, so 4 and 2, that's 6n squared. And then I've got a negative 6n, and I've got an 8n, so that's plus 2n. And then I only have one term that doesn't have a variable, so minus 12, and that is my answer there. All right, you do one.